2, 1 and done. You guys will have an assignment today and tomorrow, and then you'll have one between Wednesday and Thursday. I'll get you a study guide on Wednesday. You will have study guide on a Wednesday or Thursday, but you'll have time to work on this study guide on Friday and Monday of next week. Your test is Tuesday, right before we head off to Thanksgiving. Share with the person next to you, what is your favorite Thanksgiving dessert? What's your favorite Thanksgiving dessert? Go.
Dessert.
Okay. I hope you're getting ready for that time. We definitely have exciting plans in our family. You do get that Wednesday off as well as the Thursday. Enjoy that, because when it comes time for Christmas break, your first day off is going to be none other than Christmas Eve. Okay? So it's the 22nd and the 23rd, and then your first day off is the 24th. I don't know why the school district chose to do it that way, but they did, and that's the way it is. So on your test, okay, so if we were to, at the end of the semester, we were to say, hey, here are the 8 things that we want students to be able to do from this course, okay? Do you agree that z is equal to x minus mu divided by sigma? You agree that that's something important we need to know how to do? Absolutely. Today is another thing where it's like any kind of college class, once you step into statistics, they will all use the term confidence interval. So you can guarantee you're going to have a number of questions like that on the test. We need to be able to determine confidence intervals today, and so we will. In order to establish the idea of a confidence interval, we're going to come back to our normal distribution. This question came up on Friday for those that were here on Friday. And you can see here that when we first started this course, we talked about how 68% of data lied within 1 standard deviation of the mean. And we also talked about how 95% of the data lied within 2 standard deviations of the mean. And finally, we said that 99.7% of the data lied within 3 standard deviations of the mean. And so, Greta, on Friday, we were talking a little bit about percentiles and z-scores. Do you remember that piece? Yeah. And the z-scores are on the bottom. So like -3, -2, -1, and 0, 1, 2, and 3. These are all z-scores, okay? But the z-scores all connect with a certain percentile. For example, you might have 0.1, 0.2, 0.3, 0.4, 0.5 should be right in the middle, 0.6, 0.7, 0.8, 0.9, so on and so forth. So a z-score corresponds with a different percentile. And what we would like to be able to do today is make a confidence statement about a statistic. And that's going to be just slightly different than what we've done, but I think that you're going to do just fine with it, okay? And so, for example, when people say, what is the percent of people in the United States that approve of the current job that the president is doing? That number is currently at about 42%, which is pretty normal for a president. But what is the confidence interval on that? Because there's no way that if we asked all the people in America, there's no way it would be identical to 42%. Maybe, but probably not. It might be off by a little bit. Agreed? So what we want to do is we want to put a plus or minus on that. So for example, suppose that the president had a score of 42% plus or minus 3%. Well, we would say that if it was plus or minus 3%, we would say that that score would actually be somewhere between 39 to 45%. And we want to understand what that means. And what level of confidence do we place on that? We always like to have higher levels of confidence, but how does that work? So today, for a confidence level, for a confidence interval, we are going to use as follows, okay? We go ahead and we take the proportion, p hat, the statistic that we found for the proportion of people from the sample that said, hey, we think that the president's doing a good job, and that's going to be equal to the following. We're going to take our z-score, and then we multiply it by that margin of error or the standard deviation. And the standard deviation, again, for a statistic of p hat was the root of p hat times 1 minus p hat, all divided by m. Now, the things that we need in this situation is as follows, okay? A z-score, that's going to be determined from your confidence. So when we pick a z-score, we have to decide how confident we actually want to be. N is obviously our population size, or I should say our sample size in this situation. Sorry about that, I should say sample. The number of people that we sampled. And obviously p hat is our proportion, okay? That's our statistic that we're using. So if we're doing proportions today, then obviously you can see that as we move down the road, we're going to be looking at not just proportions, but we're going to be looking at means in those scenarios as well. Here's what's different, okay? I'm going to try to make this as clear as I can. Suppose that we want to be 90% confident. Meaning, we want to ensure that 90% of all the samples are going to lie between those two spots. Look at the diagram I have up above everybody. See how it goes 0.1, 0.2, 0.3, 0.4, and the area carries on this way? This spot right here is not for 0.9. If I have 90%, how much is left on each end? If 90% is the middle, how much would be left on each end? 5%, right? So if we're looking at 90%, that means that 5% is on this end and 5% is on this end. And so the corresponding probability that we use for 90% is not 0.9, but rather 0.95. It's the accumulation of everything to the left. So when we use a confidence interval, we don't actually use that exact number, but we got to translate it to a new one, okay? So let's try a sample and see how it goes, okay? A local newspaper recently conducted a survey among people in the city to determine how many people leave their homes unlocked while they are at home. The newspaper conducted a random sample and surveyed 145 people. We really like that they did a random sample. If they didn't, we really couldn't use our statistical methods, but they did, so good for them. The results survey indicated 64% of people leave their home unlocked when they are at home. Determine a 90% confidence interval for this survey. Tell the person next to you, do you leave your home locked or unlocked when you're at home? Why or why not? Go ahead.
When I'm at home, I'm unlocked.
When we're home, it's locked. When we're not.
Oh, what? That's so much.
When we get home, lock the door, but if we're not there.
That's good to know. We never really locked it.
Yes.
Yeah.
But our front door.
Did you play? What?
I think it's in my garage. There's always not that.
I know, I need
Okay, so let's show you how this is going to work, okay? And so it says to provide a confidence interval, and in this case, we can see that it is a proportion. And our formula is as follows, okay? P hat plus or minus our z-score times the root of p hat times 1 minus p hat, all divided by n. Again, p hat P represents the known population that actually leaves their doors locked when they're at home. P hat is our sample. When we sampled, we got 64%. We don't actually know P in this situation. We know what P hat is. Just out of curiosity, raise your hand if you do have your door locked when you are at home. Those who don't? I would be in your boat. My wife basically makes us lock the door. She grew up in the country, and now we live like in town. She feels like it's more dangerous or something. But There was a time where people were waking up in the middle of the night in their homes, and there was a person standing in their bedrooms at night as he was robbing people's places. I robbed about 16 places in town before they caught him, but that was kind of creepy. A lot of people started locking the doors a lot more. So let's go ahead and fill it out. We have p hat, which is 0.64, plus or minus. We're going to come up with z in a second, and we go the root of 0.64 times 1 minus 0.64, all divided by, what is n? 145. Everybody okay with that? Now, I want you to understand that when we try to figure out what z is, we have to focus on this 90% confidence piece. Now, I already tried to set you up for this by thinking about this. If this is 90% confidence, okay, how much lies on each side then? 5%. So the percentile we're actually looking for in order to grab a z-score is none other than 0.95. Everybody okay with that? If you go ahead and grab your statistics template that I got for you guys, I'm going to try to make this easier for you as opposed to more difficult. If you have your sheet and you want to look it up on your sheet, go ahead. But if you look at what I have here, I have a spot down here where percentile, that's all you have to do is just plug in 0.95 and it will spit out for you the exact z-score, 1.645. That way you don't have to go to your sheet. Is that okay? So you can see you can do it both ways. You can come up with the percentile and you come up with the z-score. So let's go ahead and make use of that. Okay, the number that goes in here is 1.645. Now, I would say that if this decimal is to 2 places, then this decimal should be to at least 2 places. I like to err on the side of going to like 3 places. Are we okay with that? So let's type this in and see what kind of decimal we get on this side. I'm going to go to my calculator. Why don't you make sure you grab your calculator as well and make sure you get the same decimal that I have. So I have 1.645. I'm going to multiply by the square root. I'm going to choose to use order of operations here to try to figure it out. The square root of, and I'm going to take in the top, I'm going to go 0.64 times, what is 1 minus 0.64? 0.36. So I have that in the top. I'm going to divide it by n. What is n? What was our sample size? 145. And I close my parenthesis. And see, did you also get 0.065? Okay, so I'm going to write 0.065. I don't care if you write 0.065 or 0.066. I don't care what you do that third decimal place. I usually just cut it off. I'm going 0.065. So 0.64 plus or minus 0.065. This is called our margin of error. Okay, that's our margin of error.
So like we don't want to solve it all the way.
And now we're going to solve it all the way. So just like in the quadratic formula where we subtract 1 and we add 1, that's what we're going to do right now. So I will take my 0.64 0.64 and I will subtract 0.065 and I'll take 0.64 and I will add 0.065. And since my initial statistic was represented as a percent, 64%, we're going to represent these as percents as well. 57.5 to 70.5. I don't know about you guys, but that's a little bit of a broad range, isn't it? Suppose that I wanted to be more confident. I didn't want it to be so broad. Anybody know what I could change in this problem to make sure that that was a little bit tighter? I could change my sample size. Instead of just doing 145 people, if I did 1,045 people, that would definitely tighten this up a little bit. Okay, 2 more problems to try. Let's go to example 2. Local medical facility was curious as to how many people had influenza this past winter. Influenza is the flu. A lot of times people get vaccinated for it. Did you know that the vaccination is a guess? It's our best guess for what strand of the flu is going to come up, okay? And so sometimes we guess right, and sometimes we guess wrong. I tend to get influenza about once every 5 years, and that's the way it goes, okay? Similar to COVID, okay? They conducted a random sample of 643 people, finding that 132 people had influenza. Determine a 95% confidence interval for the proportion of people who had influenza. So I go ahead and I write up my formula. P hat is equal to, P hat plus or minus my z-score times the root of p hat times 1 minus p hat, all divided by n. Anybody know what p hat is in this situation? There's no percent. What's that?
132.
So 132 is the number of people. If it's p hat, I want a proportion. If it's 132 people that got influenza out of the 643 people, how would I find p hat? I would divide them. So p hat is going to be equal to 132 divided by 643. That will give me my proportion I'm working with. And I get 0.205. So I have p hat plus or minus whatever the z-score is times the root of, and I'm sorry, I can actually just write 0.205 there. 0.205 plus or minus the z-score times 0.205. 1 minus 0.205, I did that once upon a time, I think I got 0.795. Can somebody convert that for me? What number goes in the bottom? How many people did we sample? We sampled 643, yeah. Larger sample than last time, so that should probably tighten our window, okay, which would help. Talk to the person next to you, or try to come up with what do you put in for Z in this situation? Try to figure it out. What do you put in for Z? Go. Okay, so if I have 95% confident, that means I have 2.5% on each side. Agreed? So that means 0.975 is going to be the percentile you use. That now needs to be converted to a z-score. Again, this is a percentile, not a z-score. So as I go to my statistics template here and I type in 0.975, you can see that I get 1.959, or really about 1.96 on the dot. You okay with that number? 1.96. That one gets used a lot. So 1.96. I now go ahead and do the conversion here. .96 times the square root of, I have 0.205 times 0.795, and I'm dividing that by 0.975. what was it, 643? Is that what we had? 643. And I get a grand total of 0.031. And as Maggie said, we then want to add and we want to subtract in that scenario. .205 minus 0.031. I get 0.174. And if I add it, I get 0.236. So 17.4% to 23.6%. So we would say that we're 95% confident that between 17.4% of people and 23.6% of people had the flu within the last year. Okay. Okay, this one is to, this lesson is really, they tell us in this unit we should spend about like 12 days on this unit. We really don't need to spend that much time. They get a lot of conceptual understanding. This one will summarize everything we need to know. But it says, suppose that 95% confidence interval is determined for a proportion of people who own a dog. That confidence interval was 39 to 45% after 544 people were surveyed. Which of the following is the best descriptor of what the confidence interval means? Look at A, B, C, D, read them, and take a guess. Which one do you think is the best descriptor of what the confidence interval that we determined actually means? Go ahead and talk to the person next to you. After you read them, come up with a guess. Make sure you choose A, B, C, or D. Go. Take another minute, talk about which one do you think is most accurate. Okay, this does not mean that 95% of people own a dog. We would guess that the percentage is somewhere between 39 and 45. The proportion of people who own a dog is between 39 and 45%. This is most likely, but it is very possible that the proportion is outside of that. Okay, so this is not true either. It's very likely, but it's not true. The probability that 39 to 45% of people who own a dog is 0.95, this again is very likely, but it's not necessarily true. The last one is it. What a confidence interval truly means is this. If we were to conduct this same survey again and use 544 people, we would come up with an answer between 39 and 45, 95% of the time. 95% is 19 out of 20, okay? So that means if we were to do 20 samples like this over and over again, all of them except for one would come up with numbers between 39 and 45. And that's what that truly means. It doesn't tell us exactly what it is. It just tells us that part. Last example. Pharmaceutical company is finding that approximately 6% of people using a new drug are having adverse side effects, okay? The pharmaceutical company would like to do a survey with a margin of error of less than 1%. Ooh, wow. At a 99% confidence level, we're wondering how many people should they survey. So this is different, okay? Do you agree that a pharmaceutical company, somebody who's spitting out drugs, they might want to have more confidence than, say, somebody who's running for an election? Because we're worried about people's health, right? And within the health industry, often we don't even do 99%. We do 99.99% often in order to try to become as accurate as we can. Well, the margin of error is equal to the z-score times the root of p hat times 1 minus p hat, all divided by n. That's what we're trying to solve in that situation here. And we want our margin of error to be no less than, or no more than 1%. So what is 1% as a decimal? 0.01. Move the decimal point 2 places. That equals, now we're going to have to come up with a z-score. So I need 99% to be in the middle. How much is left on each side? 0.5%, right? So that means that the spot that we're looking for is 0.995. That's my probability value. We're going to convert that to a z-score. Fortunately, we have this nice sheet that we can point to right here, 0.995. And when I do that, I get, whoop, I get 2.575. I'll do 2.576. Times the square root of. What do I put in for P? 0.06. Times 0.94 divided by n. So n is what we don't know. Everybody okay with that? Now this is going to be new for a lot of people, even those of you who are used to algebra in terms of solving this. We're running right up against time. We'll get through it. I want to solve for n. What do you think I should do to both sides first? Yep, divide by 2.576. So I'm going to divide by 2.576. So we get 0.01 divided by 2.576. I get 0.00388. I'm going to write it out a little ways. Now I want to get an n. What do you think I do to both sides now? Square it. And we square it, it gets really small. I square that answer. Okay, I get that. 1.50698 times 10 to the negative fifth. 1.5 what? 0.07 times 10 to the negative fifth is equal to, I'm going to multiply the 0.6 and the 0.94 on top. 0.6, 0.06 times 0.94. We get 0.0564. And now can I show you a trick here? This is kind of the piece that everybody's going to want to see as we just about get ready to end here. Everybody agree I want n in the numerator? Then I could do this to both sides. And what do you call it when you do this? You're taking the reciprocal. So if I take the reciprocal of this, I get n over 0.0564. I have to take the reciprocal of that. And if you have 1.507 times 10 to the negative fifth power, and you take the reciprocal, the way we do reciprocal is the negative 1 key, and we get 66,357. And finally, how do we get rid of the 0.0564 on the bottom? We multiply. So 0.0 times 0.0564. So they have to survey 3,742 people in order to achieve that. Okay, your assignment from this lesson. I'll hand it to you as you walk out the door. Yeah. Kenna, do you want to stay up for class and get your stuff? Yeah, again, if you weren't here on Friday with 13 people missing, just stay after and we'll try to figure it all out. Yep, Friday was very optional, so. Okay, here we go. So we did a worksheet. It was not easy for people. They struggled, and that's why we had it in class, because I ended up helping people for a lot of the hours. So, yes, right. There's no notes. No, this is a summary of what we've been working on. And even though it's a summary, like I said, that's why we had time to work on practice. I knew it would be hard for people, and it was. So if you need help with it, I will try. You should find the time to sit down.
It feels better.
Don't see my yeah, it is. Yeah. So no guarantee is nothing.
We should say like here, you see which one you love it. Oh, I don't know. I can't find well, I was gonna do my. It feels a lot better. It's not irritating.
Yeah, it was a joke.
Did you have that?
No,
And
it's
you're
just
kind of
sign.
like my
Just sign.
Oh, yeah. Like the
He's reloading. I'm reloading my gun.
It's like nothing. And like, what even is it? Wait, what do you have? It's like
Can I get stuff?
See, I'm so on this thing. I think you go I got this at like 7 o'clock. Oh, before 8 o'clock.
What minute out?
I think after the second. Yeah, because he did.
Wait, give me
Well, because that guys I promised the extra credit. I did not. Yeah, it was awful. I have no idea. I have to look back up at myself. I'm just gonna do it after. But I guess if you have another one, I'll do it. How's my name on it? Even if you have, and the questions
So tell me a bit.
No, I don't know.
Did I do?
There you go.
Thank you.
Okay, test scores were very high, as you can see. Some of you guys had your best test of the semester. Some of you guys did not have your best test of the semester. But overall, this is a situation where the feedback that I get, just so you guys can know my world, okay? The feedback I'm getting is the administration community is saying, why are our kids scoring this high, but yet not doing as well in the ACT? You see what I'm saying? Like they're saying if we have 3/4 of the class are getting a 90% or higher, they're like, why don't we have, a bunch of kids getting 27 or higher on the math part of the ACT? So they raise a really good point. And the point is that maybe I made the test too easy. I know that you guys don't feel that way, but I am saying that I just want you to know the world I live in. Okay, so it's not like people see these scores, they pat me on the back. They say, you need to make it harder, because right now this is a situation where we need to see a larger spread, so kids are being challenged more. When you are at your apex of learning, that is when you are at the studies show that you're kind of at your apex of learning when you are fighting for that A minus B plus spot. Okay, that like when you're fighting to get to that point, like struggling to get to that point, that's probably where you're learning at your best. And so anyway, so great job. Test scores were very high. It's going to feel good. I'm happy for you. Without a doubt, as we move on, chapter 4, and then we have word problems, and we have quarter 3, and we have quarter 4. Okay. Basically, most of the stuff we have the rest of the way is new. Okay. So it's not going to be a situation where you necessarily remember things from all the previous years. I will say that quarter 3 is generally a very happy quarter. I would say that fourth quarter is not a happy time. Okay? Last year, the college algebra class, this number right here on the next test, was a 57.4%. So that meant that over a quarter of the students in the class failed. But they're also the lowest performing class we've ever had. So, okay, that's part of it. So I do want you to know that things are going to get a little bit harder as you roll through, okay? And that's that. If that's not comfortable for you, I apologize. You should have taken underwater basket weaving instead, okay? And I just want you to know that there are some challenges coming towards you in fourth quarter. And without a doubt, if you are not ready for those, you can absolutely sign up for a different class. Absolutely. We got about 35 kids in here. You guys are great. I enjoy you. But the fact is that there were 25 instead of 35. It'd be easier to come and help the 25 who need help. So if you don't want to be part of it, that's absolutely fine. But I'm not making it easy for people. We're going to cover the content that we've covered in other years. This time of year, as I start to get, kind of stretched out a little bit in terms of my patients, I would say Friday, my first hour class, I had 11 people gone, and in my fourth hour class, I had 12 people gone. I don't know why, but for some reason, for a lot of seniors, and that'll be the case next year you guys turn seniors, a lot of times seniors approach Friday as an optional day, and then all of a sudden it becomes my problem when people miss. I don't appreciate it, okay? And then you get the whining and the complaining. People complain about how tough it is. Folks, if you wanted an easy class, take something else. If there's something that you don't like about the way class is going, keep it to yourself, because there's some people in here, like Annalise, not only did she get 100% on the test, she also got the extra credit right. You know what I mean? Like, she's like, yay, I'm in my sweet spot here. Like, let's go. Okay? like, she may not openly say it to everybody, but she's like, hey, yeah, I like going to math class each day. Like, it's kind of fun. I get to, bet on things with my friends. And what is Mr. Gens going to do, okay? So I just want you guys to be clear. If there's something that's challenging for you, don't bring the rest of the class down. Without a doubt, this time of year, a teacher's patience starts to run a little bit thin as people try to start to cut corners. December 12th, it's a Friday, okay? December 12th, it's a Friday. That is the last day in which you are allowed to retake a test in this class, okay? Now, it is true that it is not until Tuesday, December 23rd, which is really interesting. I just always wonder why schools do that. We go right up until Christmas Eve. It's like your first day off or break is Christmas Eve. I'm like, when am I supposed to shop? You know what I mean? Right? It's like, literally, the first day off is Christmas Eve, so you're just hoping you can stay awake until like 8:30 because you're just so tired from the semester. Whatever. You don't get to take a retest on the 23rd, okay? You want to retest, you get it done by the 12th. So some people are like, well, what if I don't do well in the word problem? Well, then you don't do well in the word problem steps. Study, do well, get help. If you get a 2%, then you get a 2%. Then you don't deserve an A, okay? You're not perfect, okay? You don't deserve it. Figure it out. So, talk to the person next to you. If there is a test you're going to retake, which test would it be and when would you do it? Go ahead, Todd.
I was going to say that. I was not going to say that. I love that. I like doing that. I just got confused Mr. Young, should me and Cindy go off to the hall?
Yep, you guys should go. Okay, never as good as your best test, never as bad as your worst, or somewhere between, or a little in the middle. Where are they? No, you didn't know they're still gone.
Yeah, they're
They got married.
Yeah.
Was this?
Maggie was a runaway bride. I told Maggie to be a runaway.
We have a swim.
At someone else's wedding.
Oh, yeah, because she's a teacher.
She has to stand up and say,
Oh, she is? Oh, she's here.
What happened to my mic? I don't mind. I said they should have kept Darnold when we listened to you. You were not those stupid ideas.
Yeah, like,
She did, and I know I got it wrong.
Yeah.
in some class. I know.
Jefferson, you could tell he was fighting out there. Before we dropped that one pass.
But there's
But yeah, without a doubt, JJ McCarthy, he's definitely he's got to settle down.
But he was extra math. Hey, I got X equals 0.
Me too.
He didn't put any. Oh wait, we Houston got him.
Why didn't we kick the ball? Why not just kick it out of the back of the end zone? Oh, Steve. They didn't deserve to win anyway.
She's gonna start on that vitamin C. So like, yeah, it's not every day vitamin C. I was sick for like a whole week. And then I was late in the Northfield game. And I
Well,
I played a game 6 ice and I forgot. Like,
I missed not last year, 2 years ago. I didn't go. I was literally. Oh, I know that after the different teams.
bro, how do our coach?
No fucking way. And so you're gonna show us how to do the bonus?
Yeah, also you never showed us how to do the one from the last time.
Did?
Yeah.
I think
Sure. I thought I showed you that.
No, you did, and then it's like we got distracted.
Oh, that's not really my fault, is it? Okay, boys and girls, quick to show you extra credit here. If you were to set this thing equal to 0 to find the solutions, it turns out that first thing I'm going to do is, because it's equal to 0, I'm just going to multiply through by 2. And then after I multiply through by 2, now I'm going to factor out an x. So now I don't have any fractions, and it's easy then to use the rational roots theorem. My guesses are just going to be, plus minus 1, 2, 4, 1/3, 2/3, 4/3. So you only have 6 numbers you could guess, and you know that 0 is one of your solutions. And you get 2 numbers to work, and then at the very end you have the quadratic formula that comes up with 2 imaginary solutions. So no big deal.
Wait, so how did I get it wrong?
What'd you guys get?
I just got the
Should be a 7 on the bottom there, right?
That's all we need wrong.
I think that your
again.
squares, yeah. So you're close.
I gotta find the number that went here.
Okay, I'll take it back.
I said that
Okay, well, if
once I got wrong, where I said the square root of 9 was 9. I did probably right, but then like I wrote no, I think I did it wrong. And that night I was laying in my bed. I think you did right in the there. I forgot to write anything there. But this one instead of -3 over 2, I wrote -3 over 2. So all my work showed.
But you got it was not
Oh yeah. Definitely want to try something.
So this one I don't Well, I just realized I on this. So 6 times 3 is 9. It's 18. And 18 minus 3 is 15.
4-on-1. That's a hockey record right there. Or a Green Bay Packers record. Somebody from previous class, they just forgot it here. I told them to leave it.
Wait, like right now, who has the letters?
First time?
No, that's not.
Okay. Yeah. I got the easiest test. Okay. But I've had just like the other thing. Like the one you're looking at. And well, I forgot to set, like, I forgot to not X equals to Y equals, and I realized it that night when I was playing.
This is your next target. Make this like a whole 5 course and then you can Kaylee, what'd you get?
Yeah, I know. Kaylee,
It can't be worse than me. Just how you got.
What did you get? What did you get?
I don't know how. What did you get? That's not enough that, Kaylee.
Kaylee, that's not an like.
You're disappointed because
Yeah.
Wait, what was that? Why? So you know, would you get it?
What for It's okay, Kaylee. That's so good. Kaylee, we're ready to go. Wait, you can't go over, right? You can't go over.
That's not a real thing. Yeah, it's kind of fake.
It's either be positive or not to be negative. And I really like so many. I love that.
It's just like the back end.
I know because you were just playing. You were here complimenting yourself. You were just bringing her down.
Remember when this they said that like grandma spends all this money on it? She cried. She made me so happy. She said that. That was my favorite day.
That was my favorite in your life. This crazy time. See it, maybe you're gonna take every single day. She got so mad. I did. I was like, if we can read and also it's like, and it was too, nobody's ever, like, it's always just been like, if you're not happy with yourself.
Yeah, like if you're mad at me, you say, no, at least like, yeah.
I like it.
Okay. The only warning I have for you is if you procrastinate, just warning you right now. So that's it. Flip to the very last page. Very last page of your notes.
I just love that so much.
So, if we think about the types of functions we've dealt with thus far, for example, y is equal to 4x, that's just a line. And we've looked at, say, y is equal to x to the 4th. That's a polynomial that we just finished off graphing. What if we switch the x and the y around to get like a 4 to the x? And what happens there? And so we're going to talk about the shapes of the exponential functions and the logarithmic functions. And here we want to talk specifically about if the base is greater than 1. So something like, say, y is equal to 4 to the x. And so we're going to try to use some logic here. Anybody know if I take 4 to the 0 power, anything to the 0 power is? 1. And so therefore, you know that this goes through the coordinate of 0, 1. Okay? You know that to be the case, all right? It's the very last page, folks. Very last page. Last page. So now let's think about the exponential function, okay? Y is equal to 4 to the x. Suppose we move to the right and we put in numbers like 1, 2, 3, and 4. 4 to the 4th power. Can anybody describe that number? Anybody know what it is?
16. Oh, wait.
Thank you for your answer. Yep. So 4 times 4 is 16. Good. But 4 to the 4th is
Something else.
256. Yeah. So can everybody see that when you're dealing with an exponential function, an exponential function is going to get rather large, isn't it?
Yeah.
Very, very large. So we know that from this spot, it heads on up like so.
Wait, is that area of measuring 4?
What's that?
Like the line, the point is at 4?
This is at the coordinate 0, 1. Yep. Because anything to the 0 is 1. Anything to 0 power is 1.
That's like
Now, let's focus on the left-hand side of this graph, okay? So let's just try -1. Suppose we had 4 to the -1. What does that mean?
Where'd you get 4 from?
I just pick it. Any number that's greater than 1.
Isn't it like
Yeah, it's 1 over 4, right? I suppose you chose -2. 4 to the -2 is the same as 1 over
8, 9, 16,
18. Wow.
Everybody agree that 4 to the -2 is the same thing as 1 over 16? Because it's 1 over 4 squared. And I'll write it out once more. 4 to the -4th is the same thing as 1 over 4 to the 4th, which you guys told me is 256, right?
Oh, okay, yeah.
So you can see that as you plug in negative values for x, does it output negative values? No, it outputs values that are very small.
Wait, but like. Never mind, no.
And so the values are going to be very, very small over here. And that's going to be the shape.
If it's going to be positive, how can it be on the negative side of the graph?
It's positive means it's above the x-axis. And so to Brooke's point, this function never drops below the x-axis. And therefore, we have a horizontal asymptote of y equals 0 in these types of situations. Suppose we were to change it. Suppose that number we were taking to the 4th power. Okay. Let's think about, say, y is equal to 1 over 6 to the x power. Okay. Let's think about how that might be different. Now it's a number that's less than 1, isn't it? So what if we take 1 over 6 to the 2nd power? We would get 36. It's making it smaller, isn't it? Yeah. So it still goes through the coordinate of 0, 1 because anything to the 0 is 1. But as we plug in larger numbers, it's going to draw it smaller and smaller close to the x-axis. What do you think is going to happen on the other side? Yeah, the opposite. It's going to get bigger. So they're literally horizontal reflections of one another pending that. Okay. Last piece here is that we need to add before we move on to this is the number e. E is similar to the number pi in that it is irrational. It never repeats itself. E is very important. You're taking a class called pre-calculus because when we get to calculus, we love E. So we'll share that with you when you get back.
Let's head off to lunch. Did you say let's spread?
No.
That was funny last time.
I thought you didn't get the assignment.
Oh, no.
Stats, but it's gonna make me upset.
I still freaking have my link through until 7th hour.
I don't know why everyone hates raisins. What the freak? I love raisins. And everyone just bomb. Also, raisin cookies are opposite.
Top of the division. Yeah, real good.
Oh boy, I mean, after being told that I shouldn't feel good about the win.
Well, yeah, I mean, it's hard. I mean, come on.
I'm happy.
You did it, right? I mean, it was like,
I was like, am I happy? I'm happy that we're winning the end of the game.
Yeah.
But the rest of the game does not inspire us.
Yeah. Okay. What, you're here second hour?
Yeah.
Well,
I can cover the second hour, yeah, I guess. You're right.
I mean, you could always come in, because don't you have study hall?
Yeah.
So
We
any,
have second hour though.
I have pre-calc.
Can I do my work outside of your class?
No, you can sit back in class here and do the work.
Okay.
But like right now, I just want, so we're gonna have our sixth test coming up here.
Mhm.
You haven't done any of the first 5.
Mhm.
So I just don't know what your plan is. But I do know this, I got that from the media center, and they'd like you to hand it in.
Oh, okay.
Sound good?
Yeah.
All right, we'll see you later.
See you tomorrow.
Second hour.
Maybe not first, but second hour.
No, it's coming second hour.
mind
Cooper, Tegan. I just told him, I said, I said, it's time to just say it like it is. I said, Tegan, or Cooper, I said, there's been a number of complaints from people about how distracting you are in class. And I said, it's not just my class, I said, it's other classes. And I said, you don't seem to have the self-awareness that you need in order to understand when people don't really like what you're doing.
Yeah.
I said, you just need to know that it's impacting. So I said, I obviously am not doing my job. I need to make sure that I control the learning environment better. So I said, you two want to be the reason by which we just start doing seating arrangements and we put the guys all in different corners because you can't handle being around each other. I said, then I'll do that. But I said, everybody else has been able to handle it. So kind of give me more noise when I come in. And McKenna is standing here trying to look through all the papers to find like the stuff she's missed from the last, I think she's been here once in the last 15 days. So, and you could see like she didn't want to come, like Olivia was like pushing her to come on in. So I said, McKenna, please don't do that. I said, let me just get the stuff to you at the end of class. So then she sits down and she could handle being for class for like 2 minutes. And at that point she needs to leave and go to the office. So, she comes back up and I get her stuff and I talk with her after. She's like, hey, I said, I just want you to know, like I said, you're about 2 units behind now. I said, I know that it's challenging for you. I said, and it'll be challenging for me as well if we try to get this caught up. But I said, one of the biggest challenges, I said, you're just never here. So I said, I don't know where you're at or what we need to do. And at that point, she just started sobbing, tears just pouring out.
Yeah.
Like, all right. She's the least of my issues. Because then at that point there was, I knew this was going to happen. Stupid senior class. Oh. And you know what? You know what ticks me off about it? Like Vienna. Vienna is getting opportunities her senior year. She's taking an AP statistics course, and you know what? She's doing a good job. She really is. Like, she engages with the material, she learns it, but when you have 13 people who don't show up on Friday because they feel like they need a day off, then it changes the mood of class, and all of a sudden people are behind, and then they're panicking, and it's like, I wish for Vienna's sake that she could be in, and like Chuck and Kira, I wish they could be in the junior class.
Yeah.
So we don't have to put up with all those butt heads,
Yeah.
Like, for whatever reason, I don't know why, but Savannah stopped coming to class regularly now. It's like, Savannah, you're not smart enough to just figure this out,
No.
Boy, she came on Friday and she hadn't been here for like a week and she was just lost.
Yeah, no, I don't see her even in flex very much anymore. That's like, ooh. Like, she must have gotten like her picture redone or something. So, which means that I have her ID, her new ID with her new picture. And it's like, man, how long am I gonna have to hold on to this before I see her again? In order to actually give it to her.
You study hall kids. See who's.
Chloe tells me, she's like, I have a B in that.
Yeah, no.
And it's like,
We take away the phone, that's what happened,
yep. It's almost like,
She's like case number 1
yes.
for why.
This was
this is a good idea.
necessary. Yes, correct.
I was talking about that the other day, and they're like, right, this phone thing is stupid, like, we should be able to have our phones. I was trying to be reasonable and like, why not? Like, that's just other people, like, we can handle it.
Was Chloe one of them?
Yeah, finally I'm like, Chloe, I said, I've avoided this the whole time. But I said, you went from getting like a D and an F in math to now you're getting a B. I said, it has 100% to do with your phone. And she's like, what? She's like, oh yeah.
Like, Chloe, you're the one that has said, hey, I'm doing better because.
Exactly. Have you tried loading Synergy?
Yeah. Like
Is it
how
loading
recently?
for you?
Yeah, I just got it.
My computer has struggled to load things today at all. I wonder if it's my computer or not. Using like Diane and Mary this morning. Yeah, well, you saw me, so, I mean, yeah, you heard me talk about that the other day. I just needed to take a little bit more responsibility, and so.
Yep.
Because they were all ready to do a training on like, Tuesday and Thursday this week, and then like, I was trying to help them understand, you guys, like, that might not work out, And but by the end, they realized, like, shoot, we can't do this before Thanksgiving, we're gonna do it after Thanksgiving. It's like, yep, I said, that's just, it's part of, part of what we have to do. We gotta really target a date and plan ahead. You can't, whatever.
It's like, I don't know. I don't know. Like, I don't care to do it like during second hour.
No, I get it. You just do it. So then, and so that Mary was like, she's like, well, wait a minute. Like, if we do it second hour, that means that none of my kids will really be able to be part of it.
Correct.
So, yeah. So they decided that they would really like to do it in the English classes so everybody can be part of it.
Yeah.
So they're like, okay, so we should wait till after. And it's like,
Yeah.
again, at the end of the day, like, I'm not even the one that's impacted by it at all, you know what I mean? So it was more just kind of helping them think through a process,
Like,
like,
kind of understand.
yeah.
Yep.
Well,
And like, I mean, the only reason I know that they were so tight on trying to get all their stuff together is because Rose was talking about how tight they are.
so, I think that on Wednesday, I think you and Jasmine should share some of your thoughts from the, like, getting together for the
Correct.
conference.
I agree.
Or the meeting, and
Yep.
then I think that we should talk a little bit as a department just about like some structure to how we want to move forward, like with, looking at a curriculum and expressing options. Because we don't want to be in a situation where somebody comes and asks us, so what are some curriculum options that you guys thought were interesting?
We don't have.
And we're like, oh, well, we don't have anything, you know what I mean?
Yep.
It's like,
Then you just lose it.
especially like, I mean, I get that, we're trying to have our, whatever, our learning skills and stuff, or whatever, all that done, but it's like, most people only have like 9 to do, so we shouldn't, we shouldn't have to spend too much time doing that. I got CIS stats left to do, and then I'm done. With the proficiency scales, I still have to just make up some learning cycle document to try to get an idea of what that should look like. I tried to ask Greg one day what his understanding was. And it doesn't sound like there's really anything of great significance.
No,
Because I've seen some examples where people basically have like
what was it?
a half a page, like, hey, here's what the unit looks like.
Yep.
And then I've seen other people who have like a grid, a table, where like every day is mapped out. Which to me seems more like a pacing guide, but. So I think I'm gonna take the path of least resistance on it, and just choose something I kind of already have.
Yeah, because like this is kind
Unless
of,
you guys think you got something that's.
I mean, this is kind of what we did. Where it's just like, hey, here's unit 1, link to notes, worksheets. And then put the learning targets in there. I mean, I don't know. I mean, you could add those.
Sure, but you don't have right, but you don't have.
Day by day, no.
Yeah, okay.
No.
No, this is, yeah, I mean, this is basically what I was thinking.
Yeah. Yep. Yeah, I know. It's- Yep, But yeah, I mean, I was thinking definitely to bring down, I mean, if we kind of had that lovely meeting last week, I would have, I mean, that one, I mean, at least we did learn some things, and kind of got some things, and we kind of got our foot in the door a little bit. But I was gonna,
That meeting was more for their needs than it was for our needs.
yeah. We were, hopefully,
I'm sure that there's just been a conversation with, that Dr. Heil had with Tanya, was just like, okay, where are we at with stuff?
and
she was probably
couldn't
like-
get an answer.
Yeah, and so he's like, okay, we need to.
So, Mhm. But yeah, I mean, I think the,
Somehow it was like, this one thing I still don't get, like, his daughter, she missed 3 days yesterday, or last week for me.
is she failing?
I know Zach was, so Zach was, he was out of school on Wednesday or Thursday because he was moving.
Yeah.
And he said he saw her in the middle of the day at like Quick Trip. So,
Working or just there? Just there.
going and buy something or whatnot. And so, during conferences, she came in,
Yeah.
spent like 2 hours with her
Mhm.
to get her grade passing.
Mhm. And then just fell off.
So then she came Tuesday to class, and then she missed Wednesday, Thursday, Friday.
Is she just like not even in school, or is she just?
It's a first hour thing sometimes, so sometimes it's a whole school day.
Sure.
No. It's just frustrating when they get to that age. I think they have a car, they can drive, they have the means to try to, come in earlier, stay later, do what they can to get stuff done.
Yeah. Yeah, well, it looks like B's in first and second hour, and then A's and B's and everything else.
Oh, Journey, how are we doing? Hey, Journey. I have to yell at you. Julian Cruz, did you have him last year? Nope. Intro to esports, 28%. History, 52%. English, 16%. Algebra, 50%. Earth and space science, 82%. All right, way to go.
I can tell you who that teacher is.
Woods, 56%. So why do you think he's able to pass Earth and space science with Ken?
I don't know.
Does Ken not have real grades or what?
That's the joke, is that like anyone can pass. Like kids who, I don't know how or why.
Says he got 19 out of 20 on igneous and sedimentary rock quiz.
Again, like,
14 out of 20 on his half-life quiz.
but I can just tell you that when we were doing foundations, like when we had academy still, and he was a science teacher, and then they switched to Juan, kids were doing a lot more science in foundations than they got.
Oh, I don't I'm not surprised. I'm not a big Ken Piskus fan. I mean, we had kids getting all F's in one class and getting an A or B plus or something. It's like,
Yeah.
What's going on?
And not to be mean, but it's not a B in Phi Ed or something. Where it's just like, oh,
Right, yeah.
I could see that, where you just
Yeah.
you go out and you do the thing, and then they're like, oh, okay, I can do that.
Yeah.
Like that makes sense. For some kids. Yeah, Callie was looking at this during Flex today, and I'm like, oh boy, what is this? But it was like, oh, sure, eventually I got there. It's like, oh, good. Yes.
I'm just giving the parent functions for the exponential functions from all of the parent functions for the logarithmic. But we're just gonna do transformations of parent functions, so.
Yep. So that- I just have to wait to hear their excuses.
Yeah, well, that's big right there.
What happened?
I have no idea what to.
I had to go Christmas shopping too.
I bought Drew a shirt. I don't know what to get for my parents. I gotta get Drew more.
I think I'll make his seat a little basket. And then I'm keeping on.
So, just, I remember two names for you. Before, 'cause I write, like I said, I don't even think McCarthy should be playing right now. I think Darnold should be playing right now. But that said, I'm gonna give you two names. Baker Mayfield, Sam Darnold. Two guys that the first year of the league, they did not look good. They did not. And hey, after some time, if you're doing things.
Wait. It's mine now. She didn't get it back.
So what's the?
I don't even want to. He is at 2.718. That's so cute.
He was not a pocket passer, there's no doubt.
No, he was not.
Well, hold on, we have a quarterback whisperer for a coach. He's a quarterback whisperer, that's what everybody says.
But that's.
No, I
He's a quarterback,
But then
right?
we're gonna get
Ben Johnson wants to run the ball and then pass.
But like, what you mean?
That would be a better fit. Not that I want, I did not say I want to. That is not what I said. That is not what I said.
Hey, at the end of the day, we gotta realize this. I don't care what his stats look like, the throws that he's not making, he's gonna eventually make those throws. Like, I could make those wide throws.
Okay. Alright.
He has made those, like,
You should show up to football practice.
the throws he wasn't making yesterday, those are throws he did make in college over and over. I mean, these were out routes.
The one or
These were
two
stop
times he was,
routes.
the 1 or 2 times a game he was asked.
I'm just saying, things are moving too fast for him. I'm not saying he's gonna be great. I'm just saying, but he's gonna be better than what he is. No doubt.
I made that mistake once, I'm not making it again. Yeah.
I don't see anybody talking about how good Caleb Williams was.
Yes.
Staley's the worst. People were moved to Minnesota just so they could root for other teams. This is why I kick him out. Okay, so where does this number E come from? Whenever you see the number E, you should just think of like the number 2 or the number 3 or something like that. People get confused. They see E and they're like, well, what do I even do with it? In calculus, E makes the world so nice. It's just wonderful. And I'll show you where E comes from. E is actually equal to this. The limit as n goes to infinity of 1 plus 1 over n raised to the nth power. And as you see it right now, you're like, well, wait a minute, I don't know what that means. You're right, that's some calculus. Now, when we get to the end of this unit, I can kind of show that to you and why that should make sense. But that's what E is. And it's represented by the way that things grow in nature. So, if you have y is equal to e to the x, you shouldn't hit the panic button and say, I don't know how to graph that. The whole point is E is a number that's greater than 1. So it looks just like the very first one that we have.
So if it's greater than 1, it will always look like that?
You got it, sister.
So like, and if it's in
How is it
between
greater than 1 if it goes that way?
The base E, that number E is bigger than 1. Whereas in this situation, e to the negative x, this is the same thing as y equals 1 over e raised to the x. If I use up the negative in the exponent, that makes me flip e and drop it to the denominator. Now that's less than 1, and you can see that that's going to look like that. And those are our parent functions for exponential functions. We're going to take and put those right on the front. Go to the front now.
And is this our